Okay, so today we'll be looking now at lesson 3, which is just a little bit more on the vertex form. So in the last lesson, we looked at how to graph quadratic functions in vertex form. In this lesson, I'd like to focus a little bit more on the algebra that it takes to put things in vertex form and what it takes to solve equations that are in vertex form. So we're going to start by using the process of completing the square to write each quadratic function in vertex form. If you remember from the last unit, we used completing the square to solve quadratic equations. This is going to be a very similar process, but we're not going to have the ability to add to both sides. So we're going to have one little twist. This function is in standard form. We learned how to graph standard form in lesson 1. We can also look at how to graph it in vertex form by converting it. So the way we convert to vertex form is we group the first two terms together. That's the first step. We group. The next step is to use completing the square on that binomial there. And we must have a 1, a positive 1, just like when we were solving in front of the x squared. If we don't, we have to factor it out. So we're going to take half of 4, which is 2, and square it. I added 4 inside these parentheses, so I have to subtract 4 outside of them. So this is a little different. When we use this to solve quadratic equations, we added 4 to both sides. You can maintain balance in an equation by adding to both sides, but you can also maintain balance by offsetting any change you make. So by adding 4 to the right and subtracting 4 to the right, I'm really just adding 0. So by adding 0, that's the oldest trick in the book. I didn't change anything. This must be a perfect square trinomial. The square root of that is x. The square root of that is 2. X times 2 times 2 is 4x. So this factors as x. It'll be half of that number. It'll take that sign. Or the square root of that. Same thing. Squared. And then I'll just simply combine. I'll label that step CTS, complete the square. And then that's it. So now that we have it in vertex form, we can state the vertex. And that's a technique we can use to graph equations in standard form by putting them in vertex form. Sometimes it's more cumbersome than others. Let's take a look at the next one. First step is to group the first two terms together. Make sure that they're in proper order, x squared, x, then constant. Okay, what we're going to do is we need to factor out that number because we have to have a 1 in front of the x squared. So we'll factor out a 2, like so. All right, and then I'll take half of 4, which is 2, square it, and I'll add it. So I added 4 here, so I'll subtract, wait a minute, not 4 though. That's a 4, but inside of times 2. So I really added 8. So I need to subtract 8. Another thing to pay attention to is that you're always going to put a plus here, but if you have a negative, you have to factor it out as well, which means that you could sometimes be adding out here. All right, so this is y equals 2 parentheses. This factors as x minus 2 squared, then minus 5. So I'd like you to try that. Keep in mind that on problems like this, and that, you need to factor it out so that you get a positive 1 in front of the x squared. And if it's negative, be real careful. Do your best. Don't worry if you don't get 100% correct, but try and do as much of the process as you can. All right, let's see how we did. So for this first one, pretty straightforward. Nothing to factor out, so we just simply take half of 10 and square it, so we get 25. But since we added 25, we have to subtract 25. So this is x minus 5 squared, and then 18 minus 25 is a negative 7. Telling us that our vertex would be 5, negative 7. Let's take a look at the next one. Y of x. Can't have a negative there, so I'm going to have to factor that out. I'll factor out the negative. And that switches the signs inside. Then I'll take half of 6 and square it. So that makes that a plus 9. But that's a plus 9 times a negative 1. So I actually subtracted 9. So to undo it, I need to add 9. So then that becomes plus 5. So this is a 3, 5. All right. On the next one, we'll group these two, and then we'll factor out a 2. Then we'll take half of 5 and square it. So half of 5 is 5 over 2. Squared, when you square 5 over 2, square the top, square the bottom. And so what I really did, though, is if you multiply this 2 times 25 over 4, I really added 25 over 2 because the 2 and the 4 reduced. So I need to subtract 25 over 2. This will be x minus, take half of that, 25 over 2 squared. Oh, I'm sorry. Take the square root of that. 5 over 2. Half of that. Let me just rewrite it. 5 over 2. And then 5 minus 25 over 2. Well, this is 5 over 1. So if I multiply by top and bottom by 2, I'll get a minus 15 over 2. So that means our vertex must have been positive 5 halves, negative 15 halves. All right, let's try the next one. Again, we group these first two terms, factor out this time a negative 3, which makes it look like that. Then I can take half of 6, which is 3, and square it, giving me 9. Okay, so what did I do, though? I added a 9, but times negative 3. So I really added a negative 27. In other words, I subtracted 27. I need to add 27. So this becomes y equals negative 3 times x minus 3 squared plus 17. So that tells us our vertex is 3, 17. All right, example 3.2. We're going to solve the following functions for their zeros. So there's two ways we can do this. We could expand this out and then use factoring to solve. But we don't have to because it's already in a completed square form. Simply set it equal to 0 and solve. I'm going to add 4 to both sides. Then I'll take the square root of both sides. But if I take a square root of both sides, I need plus or minus square root. So this is plus or minus 2 is equal to x plus 3. When you have plus or minus, if it's not got a square root in it, separate it and do 2 different problems. So do 2 equals x plus 3 and negative 2 equals x plus 3. You could go ahead and subtract 3 from both sides and then separate it, but I find this easier. Now subtract 3 from each side. Negative 1 is equal to x. Subtract 3 from each side. Negative 5 is equal to x. So the zeros are negative 1, negative 5. So if you can remember this process, finding the zeros of a function in vertex form is really super easy. Let's try the next one. Plug a 0 in for y. And again, we could expand the x minus 1 squared, but we absolutely don't have to. We simply isolate the squared part and use square roots. So add 10 to both sides. Divide both sides by 2. Then take the square root of both sides. But when you take a square root of both sides, you need to use plus or minus. So this is plus or minus the square root of 5. I don't know the square root of 5, and it can't be simplified. When you have plus or minus a root, just add the 1 over in front of it, making it 1 plus or minus the square root of 5, and those are your answers. Okay? So my answers are 1 plus the square root of 5 and 1 minus the square root of 5. Okay, let's try letter C. This is the vertex form where there's like an x minus 0 here. This is, again, very easy for us to solve with square roots because there's no x term. I'll just add 1 to both sides as I work to isolate the x squared. Dividing both sides by 4 gives me 1/4 equals x squared. Then we'll take the plus or minus square root of each side. When you square root a fraction, you square root the top, then you square root the bottom, and then simplify radicals, get rid of any radicals in the denominator. So the square root of 1 is 1. The square root of 4 is 2. So we get x equals plus or minus 1/2. So our 2 zeros are 1/2 and negative 1/2. All right, we'll try the next one. Plug a 0 in here. We're finding the zeros, remember. All right, we're going to work to isolate the squared portion, so I'll move the 8 over. Divide both sides by a negative 1. Then I'll take the plus or minus square root of both sides. So I have plus or minus the square root of 8. 8 is 4 times 2, which is 2 times 2. So I can bring out a 2. So it's 2 square root of 2 equals x plus 3. Move the 3 over, making this negative 3 plus or minus 2 times the square root of 2. So negative 3 plus 2 root 2, negative 3 minus 2 root 2. Okay, so what I'd like you to do is please try 3.2, A, B, and C. Please keep in mind that it's totally possible for you to get no solution if you have to take a square root of a negative. Okay, for 3.2a, what we want to do is set each one of these things equal to 0. So I'll subtract 6. Divide by a negative 1. And then I'm going to take the plus or minus square root of both sides. And then I'll move the 1 over by subtracting it. So the zeros of this function are negative 1 plus the square root of 6 and negative 1 minus the square root of 6. All right, let's take a look at the next one. We're going to again set it equal to 0. I'll add the 8 over and take the plus or minus square root of each side. Now, the square root of 8 can be simplified because 8 is 4 times 2. So there's a pair of 2's there. So there's a 2 on the outside and 2 on the inside. And I'll subtract the 6 over, so it's negative 6 plus or minus 2 root 2. All right, let's take a look at the last one. This one here is going to be a little bit different. So I'll move the 8 over. But I can't take the square root of negative 8 because it's the square root of a negative number, so there's no real solutions here. The reason why there's no real solutions is this graph doesn't cross the x-axis. If you think about your transformations, this is a parabola shifted 6 to the left and 8 up. So it's at like negative 6 comma 8. But the y value, the a value is positive. So it has a range from 8 to infinity. It never even goes to 0. Okay, another popular kind of thing to do with these kind of problems, these are questions you'll see pretty often, is to look at a graph and determine what the equation would likely be. Determining the a value could be tricky, so we're going to limit it to plus or minus 2, 1, or a half. Okay? So the equation we're trying to write is a times x minus h squared plus k. But our a value will be a half if it's flattened, 2 if it's stretched vertically, or 1 if it's not. And then it'll be negative those if it's reflected downwards. Let's take a look at our first example. The vertex is at 2, negative 6. So our equation must be y equals some a value times x minus 2 squared and then minus 6. So this is going up 1 and to the right 1. Do you see that, how it's only going up 1? That means it's just a 1 here. And usually we don't write the 1. So this is x minus 2 squared minus 6. We'll take a look at the next one. We have a vertex of negative 4 comma 6. But we're going down. Look at that. Look at how it's going down. That's a negative, and it's 2. Do you see that? So it's a negative 2 for the a value, x plus 4 squared plus 6. Give that a try with yours. Okay, on this parabola, the vertex is at 5 comma 0. And we're going downward, right? So we should expect a negative value, right? X minus 5. Remember, it's always the opposite squared, and then you can put plus 0 if you want, but it's not necessary. Now, the regular shape here should go right through this point 1 away. So do you see how this is half? It only went down half of the unit. That's because there's a multiplication by a half here. So it's negative 1/2. So it's been stretched wider. Let's take a look at the next one. We have y equals x plus 2 squared and then minus 4 for the vertex. And this is going absolutely perfectly through that 1, 1 point. So it must be a positive 1. All right, let's write the equation in vertex form of a parabola with vertex at 5, negative 4 that contains the point 3, negative 8. So these problems sometimes give students some difficulty. So pay close attention to the process. I have y equals a times x minus h squared plus k. That's my formula that I'm trying to figure out. I know that the vertex is 5, negative 4, so it's x minus 5 squared. And I know the k value is minus 4. But we've been told one other point that we go through is 3, negative 8. So what I'm going to do is I'm going to plug in this point for x and y here and solve for the last missing number that I need for my equation. So I put a negative 8 in for y. I put a 3 in for x. And we'll solve for a. 3 minus 5 is a negative 2. Then I get negative 8 equals a times 4 minus 4. Now you want to be careful here. We get so much in a habit of always writing numbers like 3x, 4x, or 4a that we get uncomfortable when it's the letter then the number. So if you want, you can rewrite that. But I want you to remember that these parentheses are around there because multiplication comes before subtraction. So don't think this is like a times 1 or a times 0 or something like that. It's 4a minus 4. I have to get rid of this 4 first. And I'll go ahead and rewrite that as 4a. Dividing both sides by 4 gives me negative 1 equals a. So my final answer is negative 1 times x minus 5 squared minus 4. That's us finding the equation. It goes through a vertex, has a certain vertex through a certain point. Give that one your best try on the next practice. A. And that's what went right there. The equation in vertex form is a times x minus h squared plus k. I'll put in negative 2 so it becomes a plus 2 and then a plus 3. That's the vertex. But it goes to the point negative 4, 5. So put a 5 in for y and a negative 4 in for x. Negative 4 plus 2 is a negative 2. Negative 2 squared is 4. And I'll write that as 4a because it's a times 4, so 4a. Subtract 3 from each side, you get 2 is equal to 4a. Divide both sides by 4, and you'll get 1/2. So our final answer is 1/2 times x plus 2 squared plus 3. All right, earlier we looked at converting from standard form to vertex form. We need to make sure that we're able to convert from vertex to standard. Recall that standard form is y equals ax squared plus bx plus c. So we simply do the simplification to make this happen. Remember that x minus 1 squared is x minus 1 times x minus 1. So I will expand this x squared minus 1x is minus 2x, and then a negative 1 times 1 is 1. Remember that when you square a binomial, you get 3 terms. It's that squared, then these two together and doubled, then that squared. Lastly, we'll simplify to get so. On the next one, we just need to be careful with the negative 2. Square the binomial, square that, multiply the two together and double it, and then square that. Then we'll distribute. And combine like terms. And that's our equation. You do have a couple of practice problems, but I will leave those to you as an individual exercise. And we'll stop listening there.